everyone. In this video, I'll explain the important interview program called program to check given number is even or odd without using arithmetic operators. Okay, so program to check given number is even or odd without using arithmetic operators. Okay, so if we pass input 2, we should print output as even. So if we pass input as 3, we should print output as odd. Okay, hope you understood input and output specification here. So first let us discuss the general program here. So afterwards let us see without using arithmetic operators. Okay. So first we should receive some integer value as input here. After that we should check whether it is even or odd. So based on that we should display the results here. Okay. So the straightforward logic is so we should collect the input first of all into some variable here. After that, so we should check so whether that value is divisible with the 2 or not. Okay. So on dividing, so with the 2, if we get remainder 0, we consider that particular number as even. If we do not get 0, if we get remainder as 1, we consider as odd. Okay. So first, let me complete that. I'll execute the program in Jupyter Notebook here. So observe n is equals to int of input. First, I'm collecting the input here. So through this statement. So next, so I'm taking expression with the help of if here. So given variable value, so I'm dividing with 2. Okay, for getting remainder, so we should use modulus division operator, right? So if we get remainder 0, means this result, whatever we'll get here, if it matches with 0, so then we should print it as even. Otherwise, if we get remainder as 1, we should go for printing odd. So let us check whether it works or not. 2, it's even. Next of all, so 3, it's odd, working for different inputs, no problem here. But the problem statement is without using arithmetic operators, right? Okay. But before to that, I'll induce one more logic here. Okay. So all of you check it once. That is on dividing given number with the 2 and multiplying with the 2. If we get the same value, same input value, then we say that it is even. Okay. So observe here, I'll type for different inputs. Okay, I'll explain for different inputs. On dividing given number with the 2 and multiplying with the 2. If we get the same input variable value, then we say that it is even. Let us take value 2 here. So 2 on dividing with 2, you'll get 1. 1 on multiplying with 2, yes, you're getting the 2 here. Next. So fine. Let us take so next even number 4. 4 on dividing with 2, you'll get 2. 2 on multiplying with 2, you'll get the 4. Okay. So you can check for the different even values here. So on dividing and multiplying with 2. So you'll get the same input values here. This expression also works. Okay. You can check for odd values also. Let us take some 3 and 5. Okay. So on dividing 3 with 2, you'll get the quotient 1. On multiplying 1 with 2, you'll get the 2. But this is not matching with the 3 here. Likewise, let us check for 5 also. 5 on dividing with 2, you'll get the 2. 2 on multiplying with 2, you'll get the 4. Okay. So means with the input variable value, it's not matching. So in that scenario, it moves to the odd. Okay. Yeah, you can check whether it executes or not here. This is the another logic we have. Okay. So remember these logics here, and now the required one is without using arithmetic. In the first logic, you observed using modulus division operator. In the second logic, you observed using multiplication and division operators. Now, the third logic you are going to observe without using say any of these arithmetic operators. Okay. So next to this arithmetic operates, what operates we have? So just like that, we should go for thinking. We have relational operates, but with that we cannot form the logic. And next, so think about the bitwise operators here, whether it's possible or not. Okay. So I'll explain one logic here. Okay. So observe everyone. I'm applying bitwise AND operation of even and one. So gives result 0. You can take so the any even number on applying bitwise AND operation for even numbers and 1 gives result 0. But for bitwise AND operation of odd and 1 gives result 1. Okay. So let us check with that. First I'll type it. Afterwards I'll explain. Okay. Bitwise operation of even values and 1 gives result 0. Next, bitwise, sorry, here it's and bitwise and operation of odd and odd values and 1 gives result 1. So let us check with this. First of all, let us check for different so even values. Okay. So let us take 2 and 1 in binary form. First of all, 2 binary form is 0010 and 1 binary form is 0001. Okay. And applying AND operation, what you'll get? 0, 0, 0, and 0. So the entire result you can observe as 0 here. Let us check for another even value now, 4 and 1. Okay. So check. So 4 binary form is 0, 1, 0, 0 here. And again, you'll get the same result. Based on this, you can understood that. So for all even values and one operation with one, you'll get the result 0. The reason for this one is for one, only the last bit sets to 1. For even values, last bit never sets to 1. Okay. Definitely this position becomes 0. And for even values, so whatever the position bit sets to 1 here. So we'll get it as 0 in the result. Because in one binary form, remaining position bits sets to zeros, right? Okay. I hope so you understood. So why we get result 0 here for this. Next. Let us check for odd values now. Odd and 1. Okay, bitwise AND operation of odd values and 1. 3 and 1. 3 binary form is 0011 and 1 binary form is 0001. 0 is 0, 0, but 1, 1 is 1. Okay, so what is the final result here? It's 1. Okay, next, if you go for checking 5 and 1 also, you can notice, you can understood the same thing here. 1, 0, 1 it is, right? Okay. Check. Again, this position becomes 0 here and 1, 1 you'll get it as 1 as once again. Based on this, for remaining values also directly you can go for so picking the answer that is 1. Why you'll get the result 1 means for all our values always last bit sets to 1. Okay. For one only last bit sets to 1, right? That's why this position you'll get it as 1 and remaining positions you'll get it as 0. Okay. Now, with the help of this logic, we can design the solution now. So that is bitwise AND operation of a given number and next of also 1. Okay, if it gives result 0, we should consider as even. If we get result 1, it should consider as odd. Okay, observe this logic, everyone. That is n on applying AND operation with so 1. If you get result 0, should consider as even, otherwise odd. Okay, let us check. So once again now, 2 it's displaying as even now. So 3 odd, yes, it's working for all inputs now. So I'm giving you remaining logics also in the comments. Okay, check once. So we have totally 3 logics here. So on dividing given number with 2, if you get so remainder 0, we should consider as even, otherwise odd. Okay, and dividing with 2 and multiplying so with the 2 by the number, if you get the same input number, then also we consider as even. If we do not get it, we'll consider as odd. And the last logic is bitwise AND operation of so given value and 1. If he gets to the result 0, you should consider as even, otherwise as odd. Okay. So that's it. These are some three different logics for designing this solution here. Okay. I hope so each and everyone understood this. So thank you.